Codeforces around 925. There were 7 problems in the contest, but I was able to solve only 6 of them. So I would mostly be discussing first 6 problems only. And before I get started, can anyone confirm if audio and everything is fine? Hello everyone. Today I would be discussing Codeforces around 925. There were 7 problems in the contest, but I was able to solve only 6 of them. So I will discuss only 6 problems. Sound is distorted. Let me try again once. The problem is I don't have a headphone, but battery is down, so I'm still trying to see if. Okay, people says audio is fine. Probably I will start for now, and let's see how it goes. Starting with the first problem, it says recovering a small string. Nikita has a strong word. Nikita has a word consisting of exactly 3 lowercase Latin letters. Letters in the Latin alphabet are numbered from 1 to 26, where a letter A has the index 1 and up to letter Z has an index 26. Encoded this word as a sum of positions of all the characters in the alphabet. For example, the word cat he would encode as the integer 3 plus 1 plus 20, like which is sum of index of all the 3 integers. Is echoing a bit. How is it now? Let me just see once more. Okay, found the issue. I did found the issue, and I think this would be relatively better now. Like it was echoing because of 2 different sources. Okay, I just realized like it was reading from 2 different mics. Yeah. So let's get started now. And like there were like the first problem is recovering a small string. It has a word consists of exactly 3 lowercase Latin letters. Letters in the Latin alphabet are numbered from 1 to 26, where the letter A has index 1 and letter Z has an index 26. Easy fact source. I can try to restart all the setup I had once. I have restarted everything once again. And after the stream, like I will cut the starting chat once again. Like hello everyone. Hello. Mic testing. Like virtual contest is a way to take part in past contests as close as possible to participation on time. It is supported only ICPC mode for virtual contest. If you have seen this problem, a virtual contest is not for you. Is not for you. Solve this problem in Archive and never use someone else's code. Read tutorials or communicate with other person during a contest. Okay, like I will start now. Like I restarted everything. So let's get started, and I will cut out everything before this chat. Note to self, like I started at around 10:38. Yeah, so let's read the first problem. Recovering a small string. Nikita has a word consists of exactly 3 lowercase Latin letters. The letters in the alphabet are numbered from 1 to 26, where the letter A has index 1 and the letter Z has index 26. He encoded his word as sum of position of all the characters in the alphabet. For example, the word cat he would encode as integer 3, 1, and 20. Like 3 is C is the third place, 1 is for character A, and 20 is for character T. Because the character C has an index 3 in the alphabet, the letter A has index 1 and letter T has index 20. However, this encoding turned out to be ambiguous. For example, when encoding the word AVA, the integer 1 plus 22 plus 1 is also 24. So if you notice, AVA and CAT were encoded into the same letters. Determine the lexicographically smallest word of 3 letters that could have been encoded. And a string A is lexicographically smaller than string B if and only if one of the following condition holds. A is prefix of B, but A is not equal to B. In the first position where A and B differ, the string A has letter that appears earlier in the alphabet than the corresponding letter in B. So like the most critical part for this problem is to understand like what is lexicographical ordering over here. So like I will take some examples to define like what is lexicographically ordering the author means over here. Okay, let's start with the problem. So like if you compare two strings and you try to find which is the lexicographically smallest string, then like you have many example. Like for example, let's say you want to compare A, B, C and D, A, B, C. And by lexicographical order, one means the dictionary order. One second, like why is it not visible? Like sorry everyone for all this use, like not really sure like why. Like it's visible, but the problem is when I am trying, like the same thing is not appearing on the screen. Okay, like looks fine. So like the problem is like the critical part was lexicographically ordering, and lexicographical ordering essentially means the dictionary order. So like if you compare two different words, like for example you have A, B, C, D, and the other word is A, B, D, E. Then if you compare like in dictionary, like this word comes before the second word. The reason why is like if you compare the words from starting, like and you see as long as the equal characters are there, then at the end of the day, either the string, one of the string would become empty, or like both the characters contain different positions. Like for example, I would like to take one more example. Like let's say this is one of the string, this is the other string, this is the other string, and like let's say we have these strings over here. Then if we try to compare the strings here, like the string which will come first among all four would be this one, because if you compare this one and this one, like the first place where they mismatch, like the character B is smaller than C. If you compare these two strings, like the first place where there is a mismatch is the first character between A and B, and A comes before B. And if you compare these two strings, although like there is no mismatch in the first three characters, but like this string essentially ends over here, but this string still continues over here. So ABA would be the smallest string. And then if you compare the remaining strings, this would be, this string would come first, because like the first character, if you compare these two, like the first character where there is a mismatch is the second character between B and C. And similarly, if you compare these two strings, like they match at the first character where the difference is between A and B. And in the dictionary order, this string would be the third string, and like this would be the fourth string. And this was essentially the idea. And now coming back to the problem, like let's see, like if we like I am still discussing the first problem. Like let's say like we have found one possible string over here using many, like whatever sum we have been given. Like for example, we have been given 24 as the sum. Let's write it as sum of three digits which are between 1 to 26. Like it can be like sum can be 3 plus 18. Then what you can notice over here is, like if you reduce this character by 1 and if you increase this character by 1, then your lexicographical string in the dictionary will increase over here, because earlier the string starts with C and something, but when you subtract -1 over here, like the new string will start with B. And like that's what you always want, right? Because you have to print the smallest first string which will appear in the dictionary order such that sum of characters is the given sum. And like once if you try to do this over here, like 2 3 19 would be the case, like assuming that the sum is 24. Now if you notice, like you can also reduce this by -1 and you can increase this by +1 again, and then you would be left with 1 3 20. And now you can also do -1 +1 +1. So your remaining string would be 1 1 and 22. So like the important thing, if you try to take more examples over here, like what you will realize is, like you should make the first character A if possible, or like, and if first character A is not possible, then you can probably try for B C D, something like that. Like the first thing to note over here is, like if you start with any possible string such that the sum is the given sum, then if you are subtracting -1 over here and if you are adding +1 over here, then either this character will become A. In that case, you can no longer do -1 over here, or this character will become Z. So in that case, you will not be able to add any more plus over here. And if your string becomes like this, then you can do -1 again over here and +1 again over here. So you would either end with Z over here or A again over here. Or like the other case is when the string is like this, then you are doing -1 again over here, -1 +1. So either this plus minus will end when this becomes Z or this becomes A. So like the possible strings you have is, so like there are 4 possible strings you can have. Like if after doing operations with the first character, either the string becomes this or the string becomes this, and then you involve the second character, then your possible string is A something or A something Z. And if now if you do +1 -1 between the first and second string, then either this becomes A or this becomes Z. That would be the only case when you would no longer be able to subtract. So in this case, like your possible strings are these, and like these are the possible strings over here. And if you notice, like this is same. So overall our answer has three possible cases. Either the answer is like this, or the answer is like this, or the answer is like this. And like you can try each one of them over here, like each possible case. Like if you want this as an answer, then notice that the value between 1 to 26 would be the third character. So overall the value of n would be between 3 to 28. In this case, this value is 26, this value is 1, and this is between 1 to 26. So the minimum value in this case is 28, between 28 to 26 plus 26 plus 153. And here the minimum value is between 1 to 26. So in this case, your value would be from 53 to 78. And you can add three different if else to try all the cases. And like that would essentially solve your problem over here. And now coming back to the intuition part, like whenever we try to find the lexicographically smallest string, our our preferred approach always is to minimize the starting character as much as possible. So like one way would be like if we try to make the first character A and see if there is a valid string over here or not. A string starting from A would be valid if the value is like these values between can be 1 to 26, these values can be between 1 to 26. And like so the first character can be A as long as the value of n is between 3 to 53. And now you can try to make further cases over here. Like what if I try to make the first two values at A? In this case, the index over here is 1, index over here is 1, and this is between 1 to 26. So here your sum would be between 3 to 28. And like this is essentially the logic. And if you cannot make the first character A, then you can try with B, C, something like that. And you can have a for loop from character A to Z, and that would also work over here. And like this was essentially the logic. Like whenever someone asks you to find lexicographical order or dictionary order something, try to minimize the next character as much as possible. If that's not possible, then take the current character and move to the next character. And I will move to the next problem now. And like there is one other alternative approach as well. Like because the string is of up to 3 character only, and each character is between A to Z, you can also do like you can also brute force on and find all the possible string using 3 for loop. Like for character C1 equal to A up to C1 is less than equal to Z, C1 plus plus. And like after for each string you can try to find the sum of all the characters, and then you can maintain a value between 3 to 78, like whichever is the smallest lexicographical, and that would also work. And yeah, like that is essentially what Subham wrote. The second problem is make equal. There are n containers of water line up. The number from left to right, from 1 to n. Each container can hold any amount of water. Initially, the ith container contains AI units of water, and the sum of AI is divisible by n. You can apply the following operation, possibly 0, the number of times you pour any amount of water from container I to container j, where I must be less than j. Any index can be chosen as I or j any number of times. Determine whether it is possible to make the amount of water in all the containers same using the operations. So like if we read over here, like let's first try to understand like what does the problem statement ask us to do. So it says you are given container water A1, A2, A3, A4, something like that. Let's assume the 5 numbers. It also gives us like sum of all the 5 numbers. Like what then it's saying is like you can pick two index, like let's say 2 and 4, and you can transfer some water from here. So let's say you subtract minus x from here and add plus x over here. Or like you can also choose 2 and 5, and you can subtract minus y from here and add plus y over here. Or you can also choose like 1 and 2. Then you can do minus z over here and plus z over here. Like the essential idea is you can always push water towards the end, but you cannot pull water from the end. And you are also given like sum of all the water S is divisible by n. So let's assign like T as the value which, and what we need is like the value in water is equal in all the value, all the arrays, so like all the buckets or whatever we have is equal. So let's call like the final value which we need as the target value T, which would be sum of all the values divided by total number of buckets or whatever we have over us. And now like the other thing to notice, like we are always pushing water over here, we can never pull water. So for example, if a1, a2, a3, a4, a5 is given to us and the final value looks like this, then for example if you look at the first three buckets, right, because you can never pull water from here, so like in the setting the value in the first three should be more than 3t. Or for example if you look at the first two index, because you can never pull water from here, so the water which is available in the first two index in the starting is always greater than 2t. And like that was the main idea. And the other way to look at over here is like if you have a1, a2, a3, a4, a5, and if you look at like from where the a3 can get water from, like it would always be the index in the starting, and a3 can never get water from this side. So like because this is equal to t, like so like whatever water you can get from here must be greater than equal to 3t, because you can always send extra water from here to here, but you can never get the required water from this side. So like if we try to generalize it for all the possible index, what you will see is like a1 must be greater than equal to t, because you can never get water from anywhere for the first index. And if you look at the first two index, like one can provide some water to the second element, but second can never get water from anyone else. And because the final value for the first index should be at least t and the next value should be at least t, like this should be at least equal to t, or like the other way. And now what you can do is like if you look at how much water you will have for the first three string, like the final water should be at least 3t. And if you notice like any of these index can never get water from away, like one can give some water to 2, one can give some water to 3, and some extra water can be sent away. Like 2 can give some water to 3 and extra water can be sent away, 3 can send extra water. And like this was essentially the generalization. Like you first find the sum of all the elements, call it S, then you find the target water you want, which is S divided by n. Then you look at the sum, like this is what people call prefix sum. Like if you take a1, a2 plus up to ai, because these can never get water from anywhere outside, this must be equal to I multiplied by t. And if this value holds for all the values of I equal to 1 to n, then you can say that the answer is yes, otherwise the answer is no. I will jump onto my code for this problem, and like if anyone has any questions I can try to summarize my approach again. Like the idea is like I first took everything as input and found the number of all the arrays, and then I maintained a final value which I want, which is final level, which is sum divided by n. And then I am maintaining the boolean value fl, you can also call it is possible. And I am maintaining the current running sum, which I call by prefix sum, which would be current sum by n. And like probably a better way to do it would be like you start with all the values, like because it's zero based indexing. Like this was the code. Like I will explain it once again. Like to summarize once again, like the first thing to note over here was like whenever you are transferring some water, like you take some index I that is less than j, and you transfer some water from I to j and however times you want. So like for example, A3, A4, A5 is there. You can take some water from A2 and move it there. You can take some water from A1, move it outside. You can take some water from A2, move it to A5. You can take some water from A3, move it to A4. And like let's call the total sum final value, which final water we need in each as a sum by like sum of all the water we have and divided by total number of buckets we have, which is t equal to sum by n. Then you will notice like if you look at the first three elements over here, then you can see like whatever the remaining part over here is like 4, 5 and water, you can never transfer water this side, but you can also always transfer water from, okay, sorry, whiteboard not visible. Like let's first call like the final water we need is sum, which is sum of all the waters by n. Then you will notice that you can always transfer water for the later index. Like you can transfer from water from 2 to 4, you can transfer water from 1 to 3, you can transfer water from 2 to 5, you can transfer water from 3 to 4, but you can never pull water from the remaining index. So if the t is the final index we need, then if you look at the first three index, then you can notice like the initial water which is present in the first three index must be greater than equal to 3t, where t is the final water unit, because you will never get water from outside over here, but you can always give water to the outside elements over here. And like this was essentially the idea. Like if you look at the initial water in the first three index, it should be greater than equal to 3t, because you these three elements can give water to the outside elements, but they can never take water from the outside element. And now if you try to generalize this part, like a1, a2 up to ai, then my claim is it should be greater than equal to I into t, because if you compare the starting I index, these can always give water to the remaining index, but they will never be able to take water from the remaining index. And like this was essentially the main idea. And like once you get this idea, like that was essentially the solution: find total water, find the final water you need, and you maintain that is possible variable over here. Then you start from I equal to 1 to n, take all the possible sums so far, and if it is greater than I into final level, answer is no, otherwise the answer is yes. I will move to problem C now. Problem C's name is make equal again. You are given an array A of n integers. You can no more than once apply the following operation. Select three integers I, j and x and assign all the elements of the array with index from I to j the value x. The price of this operation depends on the selected index and is equal to j minus I plus 1 rubles. For example, the array is equal to 1, 2, 3, 4, 5, 1. If we choose I equal to 2, j equal to 4 and x equal to 8, then after applying this operation, the array will be equal to 1, 8, 8, 5, 1. Like if you choose j equal to 2 to 4, like then you replace all the three elements by 8. Like what is the least amount of rubles or rupees you need to spend to make all the elements equal? Like one thing you notice is like as like you can always apply at max one operation. And like it was also given in the clarification, like at most once means either 0 or 1 operations. 0 would be the case when you don't all the elements of the array are equal, you can directly print 0. Otherwise you will need at least some elements. And the important thing is like you have to apply operation only once. You cannot do it two times. So for example, if we look at this array, like let's take some of the input examples. 4 3 2 7 1 1 3. In this case, if you notice, like let's say if you have only changed these values over here, then whatever value you make, this 4 and this 113 will never be equal. So like choosing this is not a valid option. Or for example, if you choose, like if you say like decided not to use the first index, then some value a1 is there, some other values would be there. And because if you never choose I equal to 1, then all the values in the array should be equal to a1. Because whatever you do with the remaining values, if you want everything to be equal, and if you are not changing the first value, then all the values should be equal to first value. Like that was the main idea. Or like the other case can be happen, like if you don't do any operation with the last index, and whatever array you change, everything should be equal to last value as well. So for example, like a1, a2, a3, a4, a5 is there, for example. Then if you say let's show, if you have chosen a2 to a4, and the cost in this case would be 3, but after this the values will only be equal if a1 equal to a5 and the value x you have chosen is equal to them as well. If you change only this part to x, then like this x should also be equal to a1, should also be equal to a5. And like this was the main crux of the problem. Like how to get all the questions in one which you can click on complete problem set over here. Like that was the main idea. Like you try two possible final values. Either the complete array is equal to a1 or complete array is equal to an. Because if you notice, you can always change like complete array to whatever value you want. In that case, your cost would be 5. In this case, or n, whatever is it. But if you decide to just exclude the first element and make everything equal to the remaining, the answer would always be less than n. Similarly, the case when you decide to only include to not use the last element and change everything over here, then the cost would be less than n in that case as well. So like you have two cases, either you choose first and last both the values. In that case, your cost would be equal to n. But if you not choose the first value, then the remaining array should be equal to first value. Or if you do not choose the last value, then the remaining array should also be equal to the last value. And like this is how you can try, like, so like you have three possible values. Either the final value is equal to first value, or the final value is equal to the last value, or you have changed the complete array. And what we have seen is like either making everything equal to first value or the last value is better compared to completely changing the complete array. And like this gives us the solution. Like we can assume something as the final value, and then we can try to remove all the values which are equal to final value we want in the starting, and all the values which are equal to final value in the end, and we take whatever remaining part as what we need in the as the answer. Like this was essentially the solution idea for the third problem. So like I take first complete array as input and like check or give is the value which gives me final value. So I try to ignore as much as values I can from the starting index. I try to ignore as much values as I can from the final array as well. and whatever remains would be the array I need to change over here. And then I am now printing like two possible cases. Either everything is equal to first value or everything is equal to the last value, and minimum of both of them. Although I can add more cases over here, but what I see is like choosing anything else outside these two values will always result in will always be the case when I have to choose both the first and last index. And the answer is n in this case. But for both of these cases, answer is less than n. So this was the idea. Like, any questions on this one before I move to the next problem? So I will move to problem D now. So problem D is divisible pairs. It says polycap has two favorite integers x and y. They can be equal. And he has found an array a equal to n. Polycap considers a pair of indexes I and j, which is I should be less than j and both of them should be between 1 to n. Beautiful. If ai plus aj is divisible by n, and if ai minus aj is divisible by y. For example, if x equal to 5, y equal to 2, and n equal to 6, array a 1, 2, 7, 4, 9, 6, then only beautiful pairs are 1 and 5. Like if you take sum of 1 and 5, the sum is 10, which is divisible by 5. And the difference is -8, and it claims like negative number is also divisible by 2. And if you look at the 4th and 6th index, a4 and a6 is 10. 10 is divisible by 5. And a4 minus a6 is -2, and -2 is also divisible by 2. And we have to find the beautiful pairs, total number of beautiful pairs in the given array. And like that. And now if let's try to first simplify, like what does this condition mean over here? Like if you take some number n, and if we say n is divisible by, like let's look at pair ai and aj, and there what is the reminder when you divide by x first? Then you know that if you divide ai by x, you will get some quotient plus some reminder. Let's call it rx. And if you divide aj by x, you will get some qjx plus rxj. Like this is from the division identity where we say like number, quotient, reminder we have. And if you try to take, like for x we need some, right? And if we take sum of both of these, then ai plus aj will become qi plus qj multiplied by x plus rxi plus rxj. And if we look at this number, if this part is divisible by x, then this integer is definitely divisible by x, so we can ignore it. And this reminder should also be divisible by x. And also here, like we have a condition, like whenever you divide and try to find the values, this rxi is less than x, and 0 is rxj is less than x. And what the essential condition we need is rxi plus rxj should be divisible by x. And if you look at some of these values, like this is rxi is less than x between 0 to x, and 0 is less than ryi less than x. So if you take the sum, like this sum would be rxi plus ryi less than 2x. So if you look at two numbers, And then if you try to find the remainder of x when you divide it by 2, then some of the remaining two numbers should either be like, there are only two numbers less than 2x which are divisible by x, which is 0 and x. So like your cases essentially are rxi plus ryi equal to 0 or rxi plus ryi equal to x. Like this gives you like two cases over here. Nothing more, nothing less. And now you can try to form some pair like, so if you look at these cases, if you have some ai and if you know its remainder rxi, you can see like what all possible values are there for yi. Like for like aj modulo x should either be equal to, if rx is 0, like this case happens when both of them are 0, and this case happens when like both of them should be at least 1, because this value is less than x, this value is less than x. There can some would be x only if both of them are greater than 0, or if their sum is 0, then both of them should be 0. So if you know rix, like you can, if this is 0, then you know that you need ryj equal to 0, and if rx is greater than x, then you need, the value you need is ryi equal to x minus rxi. And similarly, if we try to find like the value for I, which is ai is equal to like let's choose some different numbers, uyy plus ryi and aj equal to viy plus ryj. Then if you try to take the difference of these numbers, like this is x, this is y, okay, ryi minus ryj, and if this is divisible by y, then this part is also divisible by y, and you need this part to be divisible by y. So like ryi minus ryj should be divisible by y. And similarly, if you try to analyze ryi is less than y is greater than equal to 0, ryj is same, and if you multiply with -1 for this identity, this becomes -1 is less than ryj negative is less than equal to 0. And now you can take sum of these two, and you would be left with -y is less than ryi minus ryj, which is less than y. Like there is an open interval here, there is open interval here. So like there is only one value of y which is between -y and divisible by 0. So here you need like ryi minus ryj equal to 0, which implies ryi equal to ryj. So like based on the value of I and j, you can try to find like what should be the remainder for the other value when you want these conditions to be held. Now you can maintain these values in a map, and then you can try to find the final answer over here. So like I will jump to code once, and like if there are any more questions, I will try to explain once again. Like once again, like how do I form different pairs? Like the first thing I did was, like whenever we divide some number by something, then we always get a quotient. Like one second, like if you look at two pairs ai and aj, and if you divide by x, then you know that you can write it as a pair over there. Like ai, like the identity which we have learned in school, like number is equal to quotient into divisor plus divisor part. So if you try to represent that part over here, like then AI would be equal to some qi into x plus some reminder which I am calling it rxi, and aj would be equal to qj into x plus rxj over here. And we also have a condition that the remainder is less than x but greater than 0. And now if you try to add both these numbers, you will get ai plus aj, which is qi plus qj into x plus the remainder of both of them. And if the left part is divisible by x, then the right part should be divisible by x. The first, which is the multiple of x, which I have already removed because it is divisible by x. And this gives us the condition that the sum of remainder of both the numbers should be divisible by x too. Like that's how I came over here. Now I have like both the numbers should be less than x greater than equal to 0. So if I try to look at their sum should be greater than equal to 0 but less than 2x. So this gives us two cases, like sum is 0 or the sum is x, because there are only 0 and 2 which is in this range, which is also divisible by x. If the sum is 0 and because both the numbers are positive, like both the remainders should be 0. Or if the sum is x, then because both the numbers are less than x, like the only way this can happen is both the numbers are greater than x. So this gives us two conditions. Like if you fix a particular value of I and you try to find all the values of y, then you can try to predict like what should be the remainder when you divide something by x, like the remaining values of j, which would be if the remainder when you divide ai by x is 0, then for you should only look at those values of j where when you divide and you get a remainder 0. Or if the remainder is not 0, then you should look at only those values of j where the remainder is x minus j over there. Like the main idea is if you look at the value of, if you fix the value index I, then and if you look at its remainder, then you would always be able to predict like what should be the remainder when you for all the possible values of j. And similar case analysis is there when you subtract those numbers. Like if you write ai divided by ryix and ryj, then if the difference is divisible, then it says the difference of remainder should also be divisible by y. And because both the numbers are less than y, and if you try to figure out more conditions, you will get this condition: minus y is greater than difference and plus y is less than minus y is less than the difference and plus y is less than the difference. And there is only one value of y which satisfies in this range, which is 0. So here this will give you the condition that the difference of remainder should be 0, and if the difference of the remainder is 0, then both the remainders should be 0. So like after this analysis, if you fix the value of I, if you look at its remainder by x and its remainder by y, then you would be able to predict like what should be the remainder for j when divided by x and when j when divided by y. And like that was essentially the main idea. And once you figured out this, you can maintain a prefix sum which is a pair for all the remainders you have so far and all the remainders you need so far. And like I will jump to problem for this problem once. So like I maintain a map of pair, like I denotes a pair. I also taken everything as input. Now I start from index I, like just ignore this part, and I take input. And if the current value is j, then I can try to predict like what should be the value for the index, which was essentially this, like current difference multiplied by minus sign, and for y current difference should be 0. And like then you look at the frequency map you are maintaining, which is like whatever difference of I you can get, and you add whatever you have got so far. And then you look at like what pair of reminders would be there when this current value acts as index I, which is current divided by reminder and current divided by reminder, and you add I over here. So like this frequency table contains all the values which I have processed so far, and what would be their reminders when they act as I. So like first I check if the current value acts as j, then what is the reminder I need for the values of I. I add that count to my current answer. And then I say like if the current value acts as I, what would be the reminders, and then I add in the frequency map, and at last I'm printing the answer. So if there are no more questions on this one, I will move to the next problem. And now I will move to the next problem. How to make sure that I is less than j. Like what I am doing is like I am pushing values of new value of I only after finding the value with all the values so far. So like I am reading numbers in the increasing order of the index first, and this contains like all the values which can act reminders when that acts as I. Then first I check like if the current value acts as j, then what should be the other reminders, pair of reminders. I first add that as the answer, and then I add current value as the answer. Like it was the question which seeking the truth was asking to me. Had I done like first added all the reminders in the complete array, and then I tried to find for the j, like that would have not ensured I is less than j. So the next problem is Anna and the Valentine Day gift. Sasa gave Anna a list of an integers for Valentine's Day. Anna doesn't need this list, so she suggests destroying it by playing a game. Players take turn. Sasa is a gentleman, so he gives Anna the right to make the first move. On her turn, Anna must choose an element AI from the list and reverse the sequence of its digit. For example, if Anna chooses the element A with value 42, it would become 24. If Anna chooses the element with value 1580, the value becomes 851. Note that leading zeros are not allowed. After such a turn, the number of element in the list does not change. And now when it's Sasa's turn, he must choose exactly two elements, AI, AJ, where I is not equal to J from the list, and concatenate them in any order and insert the result back into the list. For example, if Sasa chooses 2007 and 19, he would remove these two elements from the list and add the integers 200719 or 192007. After such a turn, the number of elements in the list decreases by 1. So if you see like after every turn, after every NS turn, the number of elements remains same. But after every turn of Sasa, the number of elements decreases by 1. So after Sasa has played n-1 term, only one value will remain in the array. Players cannot skip the turn. The game ends when Sasa cannot make a move. That is, after n has moved, there is exactly one number left in the list. If this number is not less than 10 to the power m, where m is given to us, Sasa wins, otherwise Anna wins. It can be shown that the game will always end. Determine who will win if both of them play optimally. So like let's like try to analyze what these players are doing. And like one thing you would have noticed is like Sasa want the length of final integer as big as possible, because that like how do you compare if a value is greater than 10 to the power n? A value is greater than equal to 10 to the power m if the number has at least m plus 1 digits. If you look at 123, like this is greater than equal to 10 to the power 2 but less than equal to 10 to the power 3. Or if you look at 4, 5, 6, 7, 8, like this value is greater than equal to 10 to the power 1, 10 to the power 0, 1, 2, 3, 5 digits are there. So this value is also greater than equal to 10 to the power 4, but this is less than 10 to the power 5. So in Sasa's turn, what we need is like the number of digits in the final number we have. Like for example, if we look at this over here, in 42 number of digits are 2, like 4 and 2. If we look at 200719, allowing duplicate the number of digits are 6 over here, 200719. Or if you look at 192007, number of digits are 6 over here. So if you notice like in Sasa's turn, the number of digits never decreases over here. And in Anna's turn, the number of digits can decrease if the last number has a 0 and that comes to the front. For example, in the case of 1580, the number becomes 851. And Sasa wants the number of digits or the length of number as big as possible for him to win the game, while Anna wants it as small as possible. Because that's how, like, if the as small as possible value becomes less than m, then we are good. If it's more than m, then they cannot win over here. Like, if we try to analyze more, because Sasa never changes, like if the initially the starting one is 3-digit number and the other is 4-digit number, in Sasa's case the final number would be 7-digit number. But in case of Anna's turn, if for example 1580, if she reverses, like 4-digit number can become 3-digit number. Like the number of digits which gets removed is equal to the number of zeros at last. So like Anna's strategy is simple. The number that has most number of zeros at the end and revert it. So whatever zeros in the end are there, they would be, they would just vanish from the array. And in Sasa's case, so for example, if he has two numbers, 12000 and 1300, then if he chooses these numbers in this order, and if he creates one number 1200 1300, then Anna can never remove these 3 zeros from the end, because however she reverses it, like this will numbers will always be in between. While the other choice Sasa had was 1300 12000, but in this case the only Sasa was able to save only 2 zeros, but here he is saving 3 zeros, because whenever Anna reverses it, 3 zeros would vanish from here, but in this case only 2 zeros will vanish. So the main idea is we do not care what the numbers are. What we need is number of zeros at the end of each number. When it's Anna's turn, she will choose the number which has most number of zeros at the end and she will reverse it. So all those zeros would just vanish from the array. And when it's Anna's turn, when it's Sasa's turn, he should try to save as many zeros as possible. So what he should do is he should find the number with maximum number of zeros, and he should pick any other number he wants and then concatenate in such a way that the number which has maximum zeros, all those zeros come in between. And like once you realize this idea, what we can do is, like, instead of keeping the original numbers, we can look at like we can look at the initial length of all the numbers, and we can count like how many zeros Anna would be able to remove from the array. We subtract it, and at last we check if the number of digits of the final array is greater than equal to m plus 1 or not. Yeah, I will jump onto code once again, and like if anyone has any questions, I can take them back if before I move to the last problem for today, which is F. So like by total, I am maintaining total number of digits. I am reading array as input. First, I take current number of zeros and I count how many zeros are there at the end, which is like as long as number is divisible by 0, you increase current number of zeros by 1 and total digits by n. And then as long as the number is greater than 1, then you keep counting the total number of digits and keep dividing the number. Now after this loop, array A will contain, like, each number instead of the original number will contain the number of zeros for each number. Now I can sort it in the decreasing order, and like then if you look at the highest number of zeros would be at index 0, second highest would be at index 1, third highest would be at index 2, fourth highest would be at index 3. So in Anna's turn, he will pick the highest number of zeros, remove it. In Sasa's turn, he will save the second highest number of zeros, so Anna can no longer remove it. Then in Anna's turn, like, she would remove the third highest number of zeros, And then in Sasa's turn, he would remove the fourth highest number of zeros. He would save fourth highest number of zeros. So now if you start from 0, if you keep incrementing 2 and keep subtracting the total number of digits which Anna would be removing. And at last check if the final number of digits is greater than M, Sasa wins, otherwise the Anna wins. And this was the main crux of the problem. Any questions on this one? So if there are no questions, like I will move to the next problem then. So it's a chat screenshot. There are n people in the programming contest. By the way, this problem has a prerequisite, at least the way I solved it. So like we will try to do it. There are n people in the programming contest chat. Chat participants are ordered by activity, but each person sees himself at the top of the list. For example, there are 4 participants in the chat and their order is 2, 3, 1, 4. Then person 1 will see himself as the first, and then 2, 3, 4. The order remains same over here. If the second person sees the chat, he will see himself first and the remaining order remains same. If the third person is in the chat, he will see himself first and the remaining order of all the elements remains same, which is 2, 1, 4. If the fourth person is in the chat, he will see himself first and the remaining order of all the elements remains same. Then we are given that k people have posted their chat screenshot, which shows the order of participants shown to that user. And like we can assume that whenever that screen, like everyone took the screenshot together, so no new message came in that time. And our goal is to determine if there is a certain order which we can find for all the screens, all the messages over here. And if no such order exists, we should print no. So like this was the problem statement. And my idea was slightly tricky. I tried to model it as a graph problem. Like for example, what I did was, like let me just write the sample again. So if we look at 1, 2, 3, 4, 2, 3, 1, 4, 3, 2, 1, 4, and 4, 2, 3, 1. Then what we know is, like if we ignore this number, then like 2 should come before 3 should come before 4. If we look at this order and if we ignore this, then 3 should come before 1 should come before 4. If we look at this order, then 2 should come before 1 should come before 4. And if we look at this order, then 2 should come before 3 should come before 1. And now like one way to do it over here is, like we can create a graph where node from U to V edge will denote that U should come before V. Then if you look at it, like this will say like there are these edges in the graph. This order says like these edges in the graph. This will say these edges in the graph. And this will say these edges in the graph. And now like once you have created this graph, U to V denotes like U should come before V. Then like let's say like when will a conflict happen? A conflict will happen when we say like U1 should come before, like let's use some A based indexing. Node A1 should come before A2. We will create a edge like this. Then we say like some A2 should come before A3. Then we say some A4 should come before something. And then we ended up saying like A4 should come before A2. Like order like this is not possible. Because here we have a conflict. We are saying 2 should come before 3, 4 should, like 2 should come before 3, 3 should come before 4, 4 should come before 2. And this is not possible. So if we create this graph and if this graph has some cycle, then the answer is no, otherwise the answer is yes. And now you can use any of the cycle finding algorithm you have. Like there are some DFS based solution like detect cycle. There are many articles online. And like there is one more solution for it as well, which as seeking the truth rightly explained, like we can also find the number of strongly connected components over here. Like this essentially makes the problem easy, but helps only when you already know like what is strongly connected components. So like for that, I will give that as an homework. And I will try to briefly explain what is strongly connected component, but how do you find would be homework exercise. Okay, now like seeking the truth is also asking like interesting solution, but how do we find that screenshot? Like one thing to note here is like it can be possible that there are multiple different screenshots possible over here. What we have been asked to do is yes or no. And if one wants to solve the advanced problem, it is also possible to count the number of different possible screenshots here. And like the main idea here would be like if you look at the strongly connected component solution, like if you want to find any one of the algorithm, right? What you can do is like let's say this is your graph. Like I have only created a subset of graph over here, not all the edges. Then like if you want any one of the configuration, what you can do is in this graph you can try to find the first node which is possible over here. Like basically the first node which does not have any incoming edge. You can take it, delete it from the graph. And now like some of the edges would be removed. Then you take any one node which does not have any incoming edge. Delete it and all the edges with it. Now like 8 and 4 are the possible choice. You can also delete edge and remove it. Now 9 and 4 are the starting edges. Then you can delete this. So you would be left with this graph. And if you keep trying it, at the end of the day, either you would have an empty graph. In that case, the answer is yes. And one possible order is the order which you found. Because now no conflict exists over here. Because like you always try to find like one possible screenshot which is at the top. And everyone agrees that it can be at the top. This will give you one possible way. And like you can use the same algorithm to even find like the graph has at least one cycle or not. This will work in this case because like in each if anyone sees the order we are creating n minus 2 edges over there. And like if what strongly connected component does is it tries to compress all the cycles as small as possible. So for example, if you have a graph like this, then when you try to find strongly connected component, it will compress these graphs into one component. And it will also compress this into one component. So what you need is like, and then the new graph would have some number of edges. So if the final compressed version contains n nodes, then you know that there was no cycle in the graph. That's why nothing was compressed over here. So like the other solution was you create this graph, try to look at the number of strongly connected component. If their length is n, print yes, otherwise no. And now like one advanced problem you can try to solve is like count the number of different configurations possible here. And I believe the answer would be along the lines like the answer would either be n. Like if k equal to 1 is there, then the answer should be n. And if you have k greater than equal to 2, then I think the answer would be either 1 or 2, something like that. I haven't really tried to prove it. The way to prove it would be like you again create the strongly connected component and you try to find the number of topological orders for that graph. And you can do that by using like the same compress algorithm, like the same cycle over here. Like for example, if the graph looks like this, then you know that like there are 4 topological orders over here. Yeah, like topological order which I mentioned would also come from SCC as well. By the way, in general graph, we cannot find the number of topological orders. I don't think it's possible for the general graph. No, it claims like it is P complete. Like for general graph, it might not be possible, but I believe like it's possible to find the number of yeah, like it says some algorithms are there. So you can in fact always also count like the number of topological orders you have. And if that count is greater than 0, print yes, otherwise print no. And like this essentially completes my stream. I will take some questions from the chat if there are some. And if you want me to explain something again, I will try to do it. Like Seeking the Truth says, this solution SCC and topological order makes more sense, but the cycle deduction logic that you told, in that if there is no cycle, then the answer is yes. And what in the case could you show the code for it? In code, so I haven't written it, but you can probably, I can share some algorithms link. And the idea for cycle deduction was simple. If there is a cycle, then you have some conflicts, and the answer is no. If there is no cycle, then there are no conflicts. The answer is yes. And one way to find that is like you always pick the first node which does not have any incoming edge. You take it out, you put it as the first message, and then you delete all the edges with that node and you keep repeating it. And like that was the idea for it. And like the problem with the merge sort idea is like you can compare some pairs and it can be the case that you don't have any comparison between them. So like for after the first comparison, ignoring the first value, you know the complete order for it. So like if you have only k equal to 1, you can just say the answer is yes, whatever you are looking at it is yes. And number of possible orders are this message can be anywhere and choices. And now if you have at least 2 values, like then the 2 messages, like you have 2 choices for the first message. Either you know the order between them or you do not know the order between them. But apart from these 2 messages, you will know the complete order between all of the values over there. And if you have k equal to 3, then you can definitely do merge sort by looking at like now there would be no conflict because the third person sees like what is the order between first and second person. And like this also proves that if k is greater than equal to 3, the answer is 1, because like the third person sees the order between 1 and 2, first person sees the order between 2 and 3, and the second person sees the order between 1 and 3, and all of them know like the relative order for all the messages over there. So for k equal to greater than equal to 3, the answer is 1. If k equal to 2, then like the only problem you have is you do not know the order between the first 2 person. And like that can work fine. Like let me just show something again. So like let's say you have k equal to 2, then possible order can be like 2, 3, 4, 1. And like let's say the second order is 1, 3, 2, 4. In this case, like first 3, 2, 4, 1 is the only order, because like 2 is less than 3. So like 2 cannot be before the first number, something like that. And in this case, the answer is 1, but you can also have a case like this over here. Oh, sorry, the screen was missing. So like I took two examples. I said like if there are only 2%, their order can be 2, 3, 4, 1 and 1, 3, 2, 4. In that case, like by looking at this, you would know like 3, 4, 1 is the order. And by looking at it, you will also know like 3, 2, 4 is the order. And now you can, by this, you can predict like the final order is 3, 2, 4, 1. In this case, the number of possible orders is only 1. This example works. But the problem happens when you have the case like 2, 3, 4, 1 and 1, 2, 3, 4. Here, sorry, 1 second. 2, 1, 3, 4. Let's say this is the order 1, 2, 3, 4. Now what you know is like from here 2 comes before 3, comes before 4. And from here 1 comes before 2 and 3. This is the only case where you will not be able to predict like what is the correct order between 1 and 2. So and the number of possible ordering would be 2. So if k is greater than equal to 3, you can do merge sort, whatever sort you want, because you will know the final order for all the values. If k equal to 2, like there is only one case where you will not know the order. That would be the case then the first two values of both the arrays are equal. And if k equal to 1, you don't know the first value of the final array. Apart from that, you know everything over there. So the number of possible ordering would be n. And this essentially proves like the number of orderings are either n, 2 or 1. This happens for k equal to 1. 1 or 2 is possible for k equal to 2. And for k greater than equal to 3, number of ordering would be 1. And like this essentially completes my complete idea. Thanks everyone for joining today. I will cut like starting testing, or I will add some timestamps. So if anyone wants to look at the screen, like they know what all parts to ignore. Thanks everyone for joining. Like approx rating, if I have to guess something, like it would be, I would say it's around 1800. Because like once this idea strikes up, like it's not that difficult to predict. Like even my code is this very short. I have used AdCoder library to compute SCC, took everything as input, created all the edges, and then I have counted like if the number of components is n or not. So like thanks everyone for joining today. Like my thought process for the last problem, like when I look at it, like it's completely different from what people did over here. So like if I explain, like you will essentially get confused over here. Although I will upload my screen card, so you would see me struggling like what I was trying to do for 2 hours. But I would say let's just not do it, like it will confuse you. Like I looked at like these two people's solution and it's completely different from what I was trying over here. So for me, it was kind of hit or miss problem, and I did not hit anything over here. So what is AdCoder library? Like adcoder.jp is also a website. Like they have created a library which consists implementation of some standard algorithm which you really need. Like you can find the announcement in this Codeforces blog, and like if you just look at like the source code is available on GitHub here, and like this is the official document. If you read over here, like you can see how to install this appendix and everything over here, and you can always install it. And like it also provides us with one script using which, like, so on adcoder.jp has include adcoder works, and for other platforms like it gives one Python script using which you can import the code. So like this is the part. And like this completes today. Last question did not add any DP. The idea was some permutation combination over there. And like just look at this screenshot, man. Like for example, some cases are there where answer is 0, 1. Apart from that, there are just two formulas. Like you can read the guideline over here, like they have set up like how do you set up for your local use. And it also gives us one Python script over here. How to submit on other online judges. They are giving you some Python script. If you give it the code, like it creates one combine.cpp string. And like that was the main idea. So like I will complete today's stream today. Thanks everyone for joining.